All right, example one, part A, how can you represent a function rule? So write the equation y equals 5x plus 1 using function notation. So this is a visual we see a lot when we introduce functions to students. So you guys will probably see this again when you're reminded about what function notation is and what functions are. So just a reminder that a function is a rule that takes an input or an element in the domain. So it takes an x, that's our input. It processes the function, it does the math 5 times that value plus 1. And then it maps it to an output or an element of the range. So this f of x is the output from this element x in the domain. So to write something in function notation, if you're already given the function, essentially you're just replacing the y with function notation, f of x, and then equals 5x plus 1. So write the equation using function notation. There we go. So let's actually use this function notation. Let's make sense of, great, we keep talking about it, but what do we do with it? So in part B, what is the value of g of x equals 5x plus 1? So again, the variable, up here we have an f, here we have a g. That doesn't have any meaning. It's just our f function and it's our g function. It's kind of a labeling system, really. But this is read as g of x equals 5x plus 1 when x equals 3. So how we would do this with our function notation is they're telling us the value of x. So we could say, hey, can you evaluate g of 3? So whatever we replace because that's our x value, whatever we replace this x with this number, we are going to evaluate the function when x equals 3, and our function is 5x plus 1. So we're going to say 5 times 3 plus 1. There is no math to do over here. This is a label, g of 3. What is the value of g of 3? It's whatever 5 times 3 plus 1 is. So order of operations, we would do 5 times 3, which is 15, plus 1, and we get 16. So g of 3 is equal to 16. That is not a good g, or 3. Let's try that again. G of 3 equals 16. So this is our answer. What this means is that when our input value is 3 in our domain, the output is 16. And remember your input, output, your domain, your range, that is tied to your x's and y's. When your x is a 3, your y is a 16. Okay, so let's keep working on that, evaluating functions for different values. Here we have g of x equals negative 2x plus 3, and we want to evaluate that for x equals 4. So essentially what they're asking is, what is g of 4? They could have just said, evaluate g of 4 without this sentence right here. So what that means we do is we just take our function rule, negative 2x plus 3, and we replace the x with a 4, because that's telling us what our x value is. So negative 2 times 4 plus 3. Again, there is no math to do over here. This throws students off sometimes. They think that g is a variable that we have to solve for. So they try to divide by 4 and get super creative. That's not happening. This is a label. G is just a label. This is our g function. What do you get when you input a 4 for the x? That's all that we're doing. So negative 2 times 4 is negative 8 plus 3. We did our multiplying first. Now we have negative 8 plus 3 is negative 5. So evaluate the function for x equals 4. So we just figured out that g of 4 is equal to 5. Oh, negative 5. So when you plug in a 4 for your x, you get back a negative 5 for the y. When your input is 4, your output is negative 5. When your domain is 4, your range is negative 5. So all of that vocab is, we have some words that are interchangeable, so it's good to always keep using those. All right, our last example. Now notice this was g of x, this is h of x. They're different functions, so they have different labels. This is the g function, this is the h function. The g and the h have no meaning beyond that. But we are going to evaluate when x equals 4. So they're asking us, what is h of 4? That is a weird looking 4. Oh, that's a little better. Okay, so that's the number we're going to plug in for the x into our function rule, which is 7x plus 15. So we're going to do 7 times 4 plus 15. Are we going to do any math over here on the left? No, we are not. That's just our label. We're going to do the math over here on the right. So order of operations, we would do 7 times 4 first, which is 28. Carry down our plus 15. And then 28 plus 15 gives us 43. So h of 4 equals 43. So again, what does that mean? If you plug in a 4 for the x to your h function, you get back a 43 for your y. If your input is 4, your output is 43. If your domain is 4, your range is 43. I think I said this one already. If your x is 4, your y is 43. So, function notation. And this is something you will see in every single math class from here on out. So function notation is a big part of higher levels of math. So we're introducing it and we're going to keep seeing it for the rest of the year. So get excited about that.